Okay, so we'll just get right started here. And I'm going to do something a little unorthodox, a little strange. That's my nature. I will start by visualizing everybody here completely clothed. And right on to the experiments. People here, pretty much everybody here knows the name Benjamin Franklin. Is there somebody here that doesn't know that name? Okay. He's a pretty famous guy. He's on the $100 bill. There you go. But he's also in a painting where he, in a large group of people at a constitutional convention, the signing of the U.S. Constitution. So what I'm going to do, first of all, there is a book that we have at the office. Maybe some of you have seen it, How the Nation Was Won. If you really want to get, we don't have very many of these left, but if you just happen to,
True story.
an invitation to get to our office, take a look at that. Now we're going to start actually by just delving right into the experiments, and afterwards, people will be wondering why. So first of all, are people familiar with these? You know what these are? Yes.
Those stores electric charges.
Leyden jars. Yeah. Named after the city, Muschenbroek. Peter van Muschenbroek. It's him right there. Right. Dutch scientist, and he developed this, and so it was named after the town where he was at. And what's interesting about it is the structure of these jars. I put these are like glass jars, by the way, if you can see it. You can take a look at this and pass it around. It's a basic construction. It's a jar, glass, thin glass, and it's wrapped around with aluminum. And there's aluminum on the inside that parallels this thing. And if you can see inside, there's a ball that goes in through the cork and down here. Do that. And yes, it does miraculously store charge. And hopefully if we could get through with these experiments, which we'll go through, figure out why that is the case. And that is a collection of a lot of Leyden jars. And first of all, this thing right here, in case some of you are inquiring, this did not come till 100 years after Benjamin Franklin's experiments, which is the Wimshurst generator. And the construction of it, you just keep spinning it, and it builds up a static charge to these two Leyden jars till it reaches full capacity, and it can't anymore, so it has to expunge itself. Okay? Okay. So I'm going to be using this because traditionally the way to charge these jars involves rabbit fur and one of these things, which you do that, but it takes a long time, and I really don't want to do that. So, but we will use that in any case, just to show people. Okay, so this is a collection of his observations and experiments, which is a book that I got free on Google. And these are a series of letters to his friend Peter Cullen, whom I believe he met when he went to his trip in London in 1720s to 1727. when he was doing business up there, and he was doing he was there working on trying to collect for his printing press that he was working for in Philadelphia. So, and here's the first letter, just to kind of give you guys a sense of this. I'm going to start reading this letter here. From Benjamin Franklin, Esquire, at Philadelphia, to Peter Collinson, London. Philadelphia, March 28, 1747. Your kind present of an electric tube with directions for using it has put several of us on making electrical experiments in which we have observed some particular phenomena that we look upon to be new. I shall therefore communicate them to you in my next, though possibly they might not be new to you, as among the numbers daily employed in those experiments on your side of the waters. 'Tis probable someone or other has hit on the same observations. For my own part, I never was before engaged in any study that so totally engrossed my attention and my time as this has lately done. For what with making experiments when I can be alone, and repeating them to my friends and acquaintance, who from the novelty of the thing come continually in crowds to see them, I have, during some months past, had little leisure for anything else. I am, etc., Benjamin Franklin. So then the second letter, July 11th. So it's saying, in the last I informed you that, this basically he just talked about how he wants to engage in this, his, friends and acquaintances and so forth. So the first is the wonderful effect of pointed bodies, both in drawing off and throwing off the electric fire. For example, place an iron shot 3-4 inches in diameter, not quite that size, but both, 3 or 4 inches diameter on the mouth of a clean, dry glass bottle by a fine silken thread from the ceiling placed right over the mouth of the bottle. Suspend a small cork ball about the bigness of a marble, the thread of such length as that the cork ball may rest against the side of the shot. Electrify the shot, and the ball will be repelled to the distance of 4 or 5 inches, more or less according to the quantity of electricity put into it. I gotta try this. Now we're going to use this one because this one is actually kind of big and it's annoying to try and charge it. But now it's supposed to, there we go. So I just charged it, and let me put this over here. Man, I wish I had more room. So I'm going to put this right next to the shot.
Should we put the lights on?
Whoa. I don't know, can everybody see
Yeah.
this?
Yeah. Put the lights on.
We can see it.
What's going on here? Get over it. It doesn't want to go. It doesn't want to go.
Pushed away.
But that is interesting, huh?
Yeah.
What is going on there? So when in the state, if you present to the shot the point of a long, slender, sharp bodkin, 6 or 8 inches distance, the repellency is instantly destroyed, and the cork flies to the shot. Let me try that again. Okay, so here's my bodkin. Well, it's a little different than the one he's talking about, but it does the same. So it's not going, for some reason, it wants to stay away from it. And it's behaving very strangely. But when I do this, now it's attracted to it.
Like you discharged it, huh?
It's like it's doing something. It's like it's like going in the opposite, behaving the opposite to when it was before.
No.
Now that's interesting. Now let's take a look at this a little bit further. See what's going on here, because this is getting somewhere. Where he's doing this, and by the way, he writes these in a series of letters, and then he makes a discovery, and then he goes back to even something basic as this, figuring something out. So we're going to continue on. So, okay. So if you present with the point in the dark, you will see sometimes at a foot distance or more a light gather upon it, which everyone, you saw that spark. Like that of a firefly or a glowworm. The less sharp the point, the nearer you must bring it to observe the light. And at whatever distance you see the light, you may draw off the electrical fire and destroy the repellency. If a cork ball so suspended be repelled by the tube, and at point be presented quick to it, though at a considerable distance, 'tis surprising to see how suddenly it flies back to the tube. If I did the same experiment with this, right? Which, by the way, I will show you guys, there's something interesting about that. Even the construction of it, it's just PVC, just plastic. Notice, I do want to point out, by the way, notice the material that's been used to construct these things. Okay, and then he goes on further, describing it a bit more, even suspending a needle-like contraption, which I didn't bring with me, but to connect that to the barrel of some type of an object and putting it there and realizing that it does that. I'll just read it. Or fix a needle to the end of a suspended gun barrel or an iron rod so as to point beyond it like a little bayonet. And while it remains there, the gun barrel or rod cannot, by applying the tube to the other end, be electrified so as to give a spark. The fire continually running out silently at the point. Okay? So, in the dark, you may see it make the same appearance as it does in the case before mentioned. So then after this, he goes into certain ways where you could actually destroy that fire that he's talking about, where you can throw fine sand on it, it ruins the, charge. And you can also use smoke by making smoke from burning wood by candlelight. Even though the candle is at a foot distance, it'll see these do it suddenly. And so he goes on. So, okay. Now he's getting into something else. Now he's talking about, he's about to get into some more observations based off of some experimentation. Can people see that?
Yes.
Okay, great. Now that's it is in pencil, I apologize. But I have the power of Zoom. There you go. Like this again. Okay, now picture of two people, if they were to charge themselves with this tube and they were standing on wax, which you don't really need, but it would have been nice if I brought plastic. If I brought plastic for us to stand on. But hold on. Do you feel anything?
No.
No, you're not supposed to touch it. Put it up to sleep.
Wait a second.
Okay, it's too humid in here for some reason. That one usually works the best, but the humidity here is ruining it. So let me try this one.
We're friends, right?
Yeah, sure.
A little bit.
A little bit? All right, well, yeah, okay. Well, the humidity does also play a factor, which is kind of a bummer. But as you can see here, the picture of person at A, which would have been me, person at B would receive a charge by me exciting that tube. So a person standing on wax and rubbing the tube, and another person standing on wax drawing the fire, they will both of them, provided they do not stand so as to touch one another, appear to be electrified to a person standing on the floor. That is, he will perceive a spark on approaching each of them with his knuckle. 2. But if the persons on wax touch one another during the exciting of the tube, neither of them will appear to be electrified. 3. If they touch one another after exciting the tube and drawing the fire, as aforesaid, there will be a stronger spark between them than was between either of them and the person on the floor. Okay? So he goes on, so I won't go too much into this, but it goes in further on what is he really looking for by doing these observations. He's starting to get a grasp of the nature of how these things that are made differently, and he's going through how they behave in certain ways.
Hello.
Like one thing I will point off, which is in here somewhere down the line, but the nature of the metal itself, ouch, I just got that. The nature of the metal itself behaves differently than this. If it wasn't so humid, I would show people, because he talks about what's called an electrical atmosphere. You kind of get what those two words together imply just by your imagination. When you rub these things, people have like played around with balloons, right? And you notice that when you do this in your hair, right, when you rub it, it's sort of like as it hovers, right? Just like what the name implies by an electrical atmosphere.
Well, in the winter, when you're coming across on a rug on the floor and you touch someone, it's a shock, but it's dry.
Mm-hmm. Right. So you have these certain things, and what he's doing in these letters and during his experiments, and you could see it, that he's really taking into consideration a lot of the things in detail, what he's looking at, as opposed to just, I just read that somewhere. Yeah, of course it does that. So then he continues on from looking at this, and then he starts to get somewhere with this, saying, so if A and B approach each other, well, let's get back to this one, because I want this one. Now you can see, okay. So if A, looks like he's about to club him. If A and B sorry, I just lost my. Okay, if A and B approach to touch each other, the spark is stronger because the difference between them is greater. After such touch, there is no spark between either of them, and C, because the electrical fire in all is reduced to the original equality. If they touch while electrifying, the equality is never destroyed, the fire only circulating. Hence, have arisen some new terms among us. We say B. The body's like circumstance is electrified positively. So he's looking now, he's starting to get somewhere with this. Now he's looking at two characteristics here. Two things that are going on that are different. A is negatively, or rather B is electrified plus and A is minus. And we daily in our experiments electrify bodies plus or minus as we think proper. To electrize plus or minus, no more needs to be known than this, that the parts of the tube or the sphere that are rubbed do in the instant of the friction attract the electrical fire and therefore take it from the thing rubbing. the same parts immediately, as the friction upon them ceases, are disposed to give the fire they have received to anybody that has less. So now you're starting to see that everything, even in our daily lives, everything, this electric, these things go everywhere, and they behave the way they do even when we don't see it. So there's something in this world that is going on that can't be seen. This is something that he's getting into a little bit further, and this one will play a critical. Better not touch that yet. Okay. By the way, don't just grab one of these things. You'll get a shock and you won't enjoy it. But these things, the separable jars, this is a lot of fun. And it gets to essentially what I will show in a little bit here with Cody Jones and Lynn on what they say. Okay, so going further, I'm going to skip this part for time's sake. And then he ends this after going through some experiments, which people have seen me charge and discharge this. People have seen me do something with this cork ball. One thing that I wanted to show, I couldn't find it, but I was looking for an alarm clock. You know those old-fashioned alarm clocks with the bells?
Oh.
Yeah, those are neat because then you put the two bells on this. Now, if you look at the construction of this thing, again, I'll point this out, this came around roughly 100 years after Ben Franklin was doing his experiments. So the idea of this construction here, do you guys notice two wheels spinning in different alternate directions, right? Mm-hmm. So if I turn this, you guys can see it. Look at how close these two wheels are together and how they spin. See that? Interesting. And it's aluminum plates. And you see how this is constructed, and you've got this glass separated by two pieces of aluminum. And notice how this behaves as well, which I will show with this one when I separate it. But the idea behind this, roughly, is that once you spin this, like a magnet, a positive charge will go to one, and therefore the other side gets the opposite. So then if I do this, and this one is they call it Franklin's bells for obvious reasons. Well, that wasn't supposed to happen. Let me do that again. There you go. This is what I wanted, where it does this, although it's become a little woo. Boy, this is going real wacky. But if I had the bells, at least it would be able to ding. It would go ding. Right? This is a basic construction of even something simple like an alarm in a school. Right?
What's the ball made of?
This is cork. It's just cork. Yeah, it's just carved out of a wine cork.
It can be anything.
And how long does that frequency
You could
last?
try.
You could be a paper, or you could be a rubber.
Mm-hmm. Well, try it. I challenge people to definitely try it. If you can construct, what you could do is you could make two of these, and you could put them next to each other. And this will keep going until it just discharges, which I don't want to do. But you get the idea is that one side, just like this one where I showed it was repelled, when it repels, it has another charge, or it has the same charge as this one, or whatever, right? It has the same charge. So the idea of repelling is like, okay, well, I'm going over here because I like this one. This one's, this one's different. And then, boing, and then all of a sudden it gets the same charge, and then it goes back to this one, and then it goes back to that one, and it keeps going back and forth, right? So now, getting into this, he sends his third letter to Peter Carlsrud, the necessary trouble for copying long letters, which perhaps, when they come to your hands, may contain nothing new or worth your reading. So quick is the progress made with you in electricity, half discourages me from writing any more on that subject. Yet I cannot forbear adding a few observations on Muschenbroek's wonderful bottle. The non-electric contained in the bottle differs when electrified from the non-electric electrified outside of the bottle. In this, that the electrical fire of the latter is accumulated on its surface. Remember what I was mentioning about that electrical atmosphere? It forms an electrical atmosphere round it, considerable extent, but the electrical fire is crowded into the substance of the former, the glass confining it. And so he's going back now to the idea of the positive and negative, right? And this time he's noticing in this one, and I'll spare the reading, where he actually notices, I don't know if capacity is a word, where if you do like a certain amount of, strokes, you do this and you count it, that's the equal amount. You will always get that same amount. Even if you discharge it and you do it again the same, it'll be the same. Similar to this. Check this out. If you do this, you notice that there's a pattern. It's always in rhythm with how many cranks I am doing this, because there's only so much that these things can store because of its structure and how it's made. Ouch. Keep that there. So, going into this, which I wanted to I just wanted to show people this and get into this, which I'll get into this a bit after. But I hope that people getting a sense that these letters in a series, he's doing this, and he's very, very meticulous on how he's looking at what he's doing. And then he's adding on new things because of what's being figured out, obviously because of what was said here in the letter. There's some type of a discussion that's going on outside of these letters, which makes them do these things, and then they start figuring them out, and then they're like getting somewhere with this. So they want more. And so now, by this time, now he's going experiments confirming the above. So now he's going back to these experiments that I've already shown you, what he already stated before, only this time he has better knowledge of what he's looking at. Even something as simple as discharging this. So now I kind of wanted to give you guys a taste of these, and hopefully people can get these. You can get this, I got this free on Google. Experiments and Observations on Electricity by Benjamin Franklin. There are a series of letters and some more, and obviously that book that I showed you in the beginning. And I just wanted to exit out of this, because now you guys are looking at, you guys have already got a sense of what I wanted to present here, so that I want you to take a look at what, on the issue of why. Because really, if you really think about it, it's kind of an interesting history, and doing electrical experiments is kind of fun. You get to shock your friends at parties and all that kind of stuff. But this is also the same purpose, the same person and group that created a nation. And so there's something there's a creative quality and something that's somewhat intangible, but yet it's necessary. It's necessary. So the issue is why? Because everybody here met us from a political basis, met us at a table, or met us at a meeting. And so what does this have anything to do with a solution like Glass-Steagall? What does this have anything to do with the future of our nation. What does it have to do with arguing the difference between paper currency and gold, right? You get a lot from Ron Paul supporters, or even people in general. I find that a lot of people in general have the same similar problem, right? It's an object fixation on something that they feel is secure. Right? That's mine as long as I can get it. Yeah. But what is this? This is the same fight. That, by the way, that's a picture of the statue at Gettysburg. I think that's the Maine, right on the wheat fields, and that's the Virginia Mount right here, across the wheat field. That's where the last nasty Pickett's charge came through that, across there, and that's why he's holding his gun, is because he went, right. But anyway, they fought a war, a bloody war based on these ideas. Whether it's a nation that's important with the Constitution that does, by the way, promote the sciences. Why is that so important? Well, all you need is food. All you need is money. Why is it so important to have a society where you actually want to develop a citizen?
It moves us forward.
What's that?
It moves us forward.
Right? Yeah, it does. You think about I've asked before, the last time I did a briefing, I asked people who remember, right, when John F. Kennedy did with NASA and the space program, right? How were people that were alive at that time, what were they thinking? And I remember Bill, who's currently not here, he said it was elation. There was a sense of that we could do something, right? He said that. And so, if you think about this, now let's make something that seems intangible, even something that you can't see, let's make this tangible. Now take a look at this. I wanted to show a clip because I know some of you have seen this in the beginning before Alexandra did the briefing. And we're going to start, this is a weekly report from last week.
Oh, okay.
Okay? And this goes into Gestalt. All right.
The death of Kennedy, like most things, that lawful direction went out the window and it was supplanted by a science that was coherent with really a monetarist system of economics. So I'd like to just give people a little bit of a flavor of what this collaboration was, of because we brought it up before, that Planck and Curler had some kind of very special relationship that was pointing in the direction of where would be the next breakthroughs in physics, but that they would be breakthroughs in the domain of physics that would come out of an understanding of mind, an understanding of human creativity. So I'll just have a couple quotes that kind of at least give people a sense of what that relationship was and what the flavor of it was.
By the
So
way,
the first quote I have is one from Curler.
By the way, Curler and Planck that he's talking about, this is 200 years after these experiments.
Curler, that was delivered in 1959 at a speech he gave in Ontario, Canada. And it was a speech on where Gestalt psychology was at that time. So after discussing his ideas of, one, what is this Gestalt approach? And then more importantly, which I think is the idea that we want to lock in on, his idea of what he called isomorphism. What he meant by isomorphism was that, for example, he was looking at things like the substrate of mind, the brain, and saying that though the brain is not the mind, what you will find is that in the substrate, you'll see certain kinds of physical characteristics which are reflections of what's occurring in the mind. And he then had a more generalized idea that all of the universe is going to have reflections of characteristics of mind. And this is what he meant by isomorphism. So the idea is that the insight we gain into how the mind works will give us insight into how physical processes work, whether at the biological level or the abiotic level. So this is this isomorphic relationship. So you're saying this idea that they were working on of approaching physics from the standpoint of Gestalt psychology was starting to gain a certain fame, a certain curiosity among certain circles. And he says, blah, these other people were eminent physicists. Then he says, Max Planck once told me that he expected our approach to clarify a difficult issue which had just arisen in quantum physics, if not the concept of the quantum itself. Several years later, Max Born, the great physicist who gave quantum mechanics its present form, made almost the same statement in one of his papers. And he goes on to mention a couple other physicists. But here you have, again, Max Planck told him that he thought that this approach that they had, this Gestalt approach, would lead to the resolving of new problems that had arisen in quantum physics, if not solve the concept of the quantum itself. And so you see, Planck had an insight as well that, hey, this is the approach we need. We have to start from mind if we're going to resolve some of these very paradoxical questions that are arising in the domain of the quantum. Now, just to give you a quote from Planck, from a book that he wrote, it was written towards the latter part of his life. It's called Where is Science Going? And sort of his reflections on the last 50 years of science, where things were headed. He has a lot of discussion there on free will, etc. But you'll see, if you listen carefully to what he says, you'll see that same quality of a Gestalt approach to physics in this. The idea, just to people who don't know, Gestalt is the idea that things are organized top-down as wholes. That the parts, that wholes are not built up by the interaction of parts that build up to a whole, but actually you have a concept, a one, which organizes like a potential all the parts that are interacting. So the parts are really just a function of the organizing principle of the whole. And that was the way that the Gestalt psychologists approached the mind, that the mind sees wholes and fills in the pieces from the whole. And so here's what Planck had to say in discussing where things now were headed as we moved into the advent of the creation of wave mechanics and quantum physics. And he says, in opposition to what had been the dominant type of physics, Newtonian physics, he says, on the contrary, according to wave mechanics, the picture must be held before the eye as a whole, and its movement must be looked upon as arising from the individual and mutually differentiated integral movements. From this, it follows closely that not the local force, as in Newtonian mechanics, but the integral force, that is to say, the potential, enters the fundamental equation. So as he said, this must be held before the eye as a whole, and that potential now becomes the more primary element, not the interaction of the pieces, but what's the potential, what's the field of the whole, which is governing all the internal relations.
Okay, so that's interesting. 200 years of scientific development, right? And now we're at a fight. The difference between the Gestalt, right, the whole, and how the mind acts, and what the mind is, right, and the nature of it, versus the God particle or a little piece of thing or dirt. Lynn likes to make joke about it, looking at the nature of the universe from a dirt, at trying to find the smallest dirt, And so one thing that I did want to show, this is kind of related. I got this idea from reading let's do this again. I wanted to show people. This is neat. Now, charge it. And now that it's charged, well, I can show people. Look at this. And then you can discharge it. Now that would hurt. Nobody should. touch something like that, right? So, try it again, right? Okay, now, I want to show you this. Now, so, I hope everybody can see this. So, I'm going to take this off. It disassembles, right? So that you can do that. And so, once you do this, it becomes safe to touch. Where's the charge? Where's the charge? The little preacher at that church. Where did it go? Where's the charge? Where did it go? So, but we put it back together again. And then, wow, something that wasn't there, something that people just ignore in their daily lives that can affect them. Which is probably why you got a lot of people demanding certain things, even though they kind of don't know what it is yet. If you heard from Alexandra's briefing, you get a sense of that. What's going on in our in this world? I better discharge this. Okay, so now I wanted to show that and then just kind of open up for a discussion after we kind of get a sense of this, because this whole thing is pretty much it is integral. And as I mentioned in the beginning, Ben Franklin, right, the same guy who did these experiments, signed the Constitution of the United States. Right? We've had bloody wars, based on this idea of defending it. And now other countries are starting to say, I kind of want something like that. People don't really quite got a grasp of what it is that's really important. Is it your money, or is it the creation, what your kids are going to be, and what is their outlook for the future? And so I wanted to end this with what Lynn said in response to Cody, because it goes into this, and then you kind of get a sense of that economic picture.
What has just been said in both cases converges upon an elementary concept, and it go back to the question of the Gestalt. That's the way the universe is organized, actually, and there's always an end result. But the problem starts when people try to say that we begin, as the Gestalt tries to attack this problem, that we start from a particle or a set of particles, and by combinations of these particles, we can generate a universe. And this is actually the way the common argument is made by the mathematician. It's this kind of perception, but it actually works in the opposite way. And I know from experience, particularly because of my age and so forth, how some of these things work. The human mind works as a unit. It does not work as parts. It never did. It's not a mind if it works as parts. Matter of fact, you want to find a real case of psychosis, you find a person who really breaks everything down into parts and then tries to explain how these parts interact. And you will find a certain kind of lunacy, which is a product of this kind of passionate concern for perfection. The point is that we all, if you look at the behavior of human memory, which reveals this, and it reveals it in terms of the experience of finding a loss of memory and the effort to recover it. What this leads to is what came out of this discussion itself. It comes out of the fact that you are trying to find, you realize there's a wholeness, and the only way you can recover from a loss of memory is by regenerating it, not reconstructing it. Because the whole always has a characteristic which is indivisible. And therefore what you must always do is be able to go back to the whole of your memory and find what is the composition of the memory. Now what people do when they get these jerks of memory, temporary memory loss, they go through an experiment in their own mind, of Gestalt experiment, of trying to say what is the pattern in which this missing thing is located. And that's how it works. The same thing here. And the creativity and insight, or what the definition of insight is which is what the Carlsrud got into. This sense of insight, that the essence is the insight into the universal. The problem comes from a number of sources which I've been treating for some years now, that the idea of sense perception, the attempt to explain everything in terms of sense perception, which means that in that case you're reducing things to particle senses and you're making another big mistake. And the big mistake is the assumption that sense perception, the experience of sense perception, is the source of truth. And that is not true. We have another aspect. You think about in any kind of physical science, you try to derive the general from the particular, or the general from the particulars. And it doesn't work that way. That's not the way the mind works. The mind does work as if the mind is a uniform experience, and a unified experience. But you don't know it really, you're not conscious of it as a unified experience. But if you have come to the point that you know it's a unified experience, then your search of memory, or the equivalent of memory, for solving this problem, then leads you to a Gestalt image. You say, well, look, this is absurd to assume that human intellect starts with dirt, pieces of dirt, which is what most people teach, pieces of dirt, theory of ideas. Actually, we know that we are informed by the fact that our memory is corrupted by sense perception. And the biological nature of sense perception is to try to do a reductionist view. What people then do when they come with a real piece of idiocy, they say, well, let's break everything down into parts. And now let's reconstruct the thing on the basis of the assembly of the parts, which loses it. Now this happens in a certain way, in a peculiar way, in terms of sense perception, biological sense perception. We assume that the biological experience of the mind as a biological experience is the source of the elemental elements of truth. Fact. We don't realize that there's something else, and because we depend to a pathological extreme in many cases, that the biological approach to experience, the emotional, intellectual experience, is valid, is the basis of truth. It becomes a ridiculous thing. Here we have non-living processes. Did you ever have a non-living process make a discovery? Right? All right, so but we start there.
Right.
That's where you start with mathematically. You start with that. And then you go to another level. And the same thing happens. And the problem you find out is that what we think of as our intellect tends to be organized actually pathologically in terms of sense perception. And by sense perception we mean a biological event, a biological fact, the interaction of a biological process. So after all, it's not elemental. Then you find different states in the universe, in which you have different combinations of this. They're also not elemental, which is where the Gestalt question comes into experience. That the human mind represents an attitude toward the way we think about the experience. And we have a level, we have 3 levels we're aware of. None,
It goes on, but without having this, you know, because it's imperative that people get the idea. Now, what they're also getting into with this discussion, how many people watched this? This was last week's week before.
I started to, but I realized it took too much concentration.
Okay. Well, it is very interesting, because like I said, they were getting into something else which is related to the development from what was originally looked into. Right. And I think from there, I wanted to just open up for discussion, and obviously people can play with the trinkets safely. Have fun. But one thing before the last thing I did want to say was, with this, people will start to get a sense, an interest for real science. If you're looking at it from that standpoint, as opposed to like, oh, I gotta read that, you know, like a textbook kind of thing, because it was kind of boring to look at science from that standpoint. But to really look at it from a totally different way, the way that Lynn just described, and the way that we did it here, as opposed to just simple lecture. But I hope that if people are a little tantalized to want to be able to play with these things and figure out what's really going on in that unseen world. And so with that, from the political standpoint, after what Alexandra said, we do have to win the fight, and we're taking over Washington, D.C., as she has explained in the beginning. We have now a dominating presence there, and the fight to get Glass-Steagall to remove Obama, right? And we have to do this for real, and it involves the population. And so we need the resources in order to keep that going while we keep coming up with more material to be able to disseminate out into the general public, east to west coast, to effectively create a shock front to do that. And so people can write out a check for $500. You can do that. Do that here to LaRouche Political Action Committee. And other than that, we also need people that actually got a sense here today on what that really is. Try and get that across to somebody else, because that's what we really have to iron out. I mean, you have no idea how many people we get every day coming up to our tables going, "What are you going to replace them with? How are you going to fix it? We should have gold. We should fix everything to gold. Gold currency. Gold. We should go back to that.
How many
Go back to
good
this."
things we have in planet?
Right. It's a panic-stricken population that's immediately, you know, I'm from the Northwest, and you have no idea how many people I get up there saying, "I got my guns, I got my ammo, and I got the Mount Rainier."
Seattle?
Yeah.
That area?
Yeah.
Ah,
In Oregon, they say, "I got Mount Hood."
What?
yeah, Mount
Mount
Hood.
Hood.
Yeah.
What do you do there?
Well, it's the same thing, you know. People want to run to the mountains with their guns and food. That's not gonna work.
We have the cats.
The Catskills. Yes, sir.
Well, we know what electricity is. It's the movement of electrons. And it was a British physicist, ironically, J.J. Thomson, that discovered the electron in the year 1897, working with a cathode ray tube. It was connected to an electrical outlet, and there was
That's actually
one
not-
gas in the tube. It was
That's actually
almost a
not
perfect
true.
vacuum, and he noticed that,
Eugene,
you know, it
Eugene,
started.
Eugene,
let's let
Eugene.
people
That's not-
ask some I'm
Eugene.
questioning.
Relax, relax.
Yeah,
I
but
under-
I'm
I
just
under-
saying,
I
he
know what
discovered
you're
the
saying,
electron.
but you got the point that I'm trying to get across.
Particles, yeah, it's electrons from the atoms, the outer parts of the
You believe
atom.
everything you see on the news, huh?
We're
No,
looking
this
at,
is
we're looking
historical.
at the whole thing.
All right, all right.
Opposed to the atomic.
Yeah, there you go, yeah. Because it's like, why, it takes the fun out of it when you look at it. You gotta, for kids to show them something and they're just like, oh, hey, I want more. Let me see how this works, That's what you want. And you want to do this and you want to create a society where people are going to have the freedom to do that. People think freedom is, oh, I can do whatever the hell I want. I could physically assault you because I don't like your political views. That's my freedom, right?
Yeah,
That's
like
not
the
freedom.
shooter, that he did whatever he wanted.
Right.
And it
But-
was tragic,
So,
Thank
Alright,
God
so-
they got him, they caught him.
All
So
they-
the
he
idea
was
here
waiting
is
to be
different.
caught.
yes.
Didn't get him, he was sitting there waiting. So-
Yeah, but the police.
We have to leave early, but I just wanted to say that, also for those who weren't here before, I'm an organizer in Copenhagen, Denmark. Yeah, and at the beginning of this fight for Glass-Steagall, it was in the United States that the burden was on you to get this through in the United States. And then things started shifting when the euro started collapsing and the European nations started going bankrupt. Then we had a tremendous opportunity because people were looking and saying, our nations are being destroyed, the nation of Greece, the nation of Spain, of Italy. Where we are is a kind of very privileged, where the economy in the northern countries are doing much better, but even there are tremendous cutbacks going on. So now we have a situation where there's a mutual effect like these sparks. Okay, you have the United States political situation on one side and the European on the other side. And everything that we can get going here then makes it able for us in Europe to do something, say, look what they've done in the United States. And everything that we can do in Europe makes a spark over to here, saying, look what they're doing in Europe. They're like this with the British. They're starting to go with Glass-Steagall. That sends sparks all throughout the United States.
Right.
So anyway,
It's a shocking truth.
it's up to us all, but go out there and do as much as you can from your side.
All right, good.
Thanks for